All right. Good. So, well, hope everybody's having a good time here at Derbycon. Yeah. 7 years of it so far is going strong. I've been here every year. Loved it every year. Love coming back. So, as I hope everybody's in the right room. You can read the slide. You can read your schedule. If you're not here to hear us talk about random story about how we went through the process of trying to write our own RATC2, whatever you want to call it, you're in the wrong room. Or you can just sit around and listen to us make fools of ourselves and try to tell a story up here, then try to get y'all to laugh somewhere along the way. So, one thing I will say is, this is came as How about now? Oh, there you go. It's coming out a little bit, so sorry. I'll hold on to it. So, this talk came out as a sort of a side effect or follow along with a tool that Bill and I wrote earlier this year. We actually were trying to write a fairly full-featured command and control, RAT, whatever you want to call it. And in the process, we realized that we were going through a particular process of building one out that other people might find interesting, or the steps that we went through, or it might apply to other things other than just writing this, but other tools in general. So we don't care. Why not? Let's write it up as a talk and come out and present it. We're not presenting that tool. We're presenting the process that we built that tool, as well as some of the steps along the ways with code and demos and what have you. All the code will be out on GitHub at some point later today, because I didn't have Wi-Fi or internet before the presentation, and I forgot to do it. I'm running late because I'm lazy. So it will be up there. You'll see my contact info at the end. Hit me up or follow me on Twitter or something. I'll post it out there. So go ahead and get started here. First of all, the obligatory who am I slide. My name is Adam Compton. I've been in the InfoSec field, somewhere in there, for around about 18 plus years. During that time, I've done programming, pen testing, research. Currently, I work for Rapid7. So does Bill here. This isn't a product for Rapid7, but they paid our way, so we put their name up there. Oh, on the first slide we did. So that's enough. Enough for that. But yes. Who am I beyond that? Father, son, husband, brother. Love my kids, love my family. It's with their help that I get to come out here and do stuff like this. My wife and son is actually with me right now. They're out playing somewhere. I don't know. And yes, it says a hillbilly, born and raised in, well, most of my life raised in Eastern Kentucky, back in Pike County. Hillbilly heritage, all that. Love it. And, it's not just the overalls, but they're comfortable, and it's nervous and hot, and it helps. And so, yay. All right, enough about me. Let's hand over to Bill a little bit.
Hey everyone, I'm Bill Harshb. So yeah, I work with this crazy guy. I'm just a pen tester who enjoys programming. I don't have a cool picture with aviator goggles and hair curlers in my beard because I don't have a beard. But yeah, I've been in InfoSec for like 10 years, pen testing for 5. So, yeah, that's, I enjoy bicycling, hiking, things like that, just normal stuff, I guess. So I guess to kick off our presentation here, we got some dogs with,
Your sisters? What?
Oh, wait, did you put this in there?
Yeah, that was you.
Oh, sorry about that.
Co-workers.
Yeah.
No, kidding. So, no, we're not above cheap laughs.
Yeah, we're fishing for cheap laughs here, so.
Sorry. It helps.
So yeah, I guess an actual agenda would help. So get over stage fright and get started. I don't know if that's done, but it's in progress. So we talked about ourselves, present the agenda. That's what I'm doing right now. And then we're going to ramble even more about this story about how we accidentally created this C2 rat botnet, whatever you want to call it. Yeah. This haphazard path of chasing down code and figuring out, well, hey, let's try this, try that, and suddenly we had a working product. So we can talk about that, whatever else, meandering, take questions, and then probably go get drinks later.
Yeah, so it's always good. It's Derbycon, come on.
So basic terminology, if you're not aware, I'm sure everyone already is, but RAT, remote administration tool, so that's like old school back orifice, things like that. C2, command and control, similar to a RAT, but we're kind of defining RAT as sort of one-to-one shell sort of stuff.
Yeah, whereas RATs out there, things that are considered a remote access tool, it can have multiple of these, but it's usually server to node, server to agent, one to one. You might then move to another one, do it. stuff like that. Command and control it can send stuff out to multiple nodes at a time, stuff like that. That's fundamentally the biggest difference between the two. Other than that, they're effectively the same, just one does it, just how many targets you're dealing with. So.
Yeah, and for us, C2 means sort of like there's a master node or a master server and then nodes where like you're issuing commands out sort of thing. So it's not like a peer-to-peer super advanced, I guess, C2. Botnet, which, of course, stands for robot network. It's like C2, but it's got the hacker connotation, I guess. It's, only bad people use botnets, but we like botnets too. Yeah. So, I mean, in short, it's basically all just distributed computing or some flavor of that, right? So, what we were doing is sort of defining, what sort of components we want, our distributed computing environment to do, like push-pull files, exec commands, things like that.
Get to that on the next one.
So yeah, this kind of transitioning. So yeah, that sounds pretty much the same, right?
Yeah.
So, common functions, as I said, raccoon, cat, encrypted communications, upload, download files, exec system or shell commands. So, when we were building this, we're security professionals, right? And we should probably encrypt everything we're doing.
Right.
So that was kind of one of the first things after we got, the chat portion of it working, I guess.
Yeah. We'll step through all this stuff.
Yeah, just a little bit of a preview here. So yeah, they're, basic functionality, I guess, and then I guess more cheap laughs.
Yeah, more cheap laughs. Everybody loves puppies, especially when they're hanging in onesies from a clothesline, I guess. So. But yeah,
So yeah, well, I'll hand it off to Adam. Right. He's the master storyteller here.
So, thank you, sir. Yep. All right. Instead of boring you all with we probably will bore you anyway, so don't worry about that. Try to do it in a little more of a flowing dialogue. Well, no, it's just story time. Just stick with story time here. So, where this all originated from was we were out on an engagement, setting out a customer site, wanted to communicate back and forth with each other as things are going along. But the problem is we're on an internal network, didn't have access to the internet, things like Slack and all that don't work. So we couldn't really use that to communicate. We're not in the same room, physically located around the building. We're lazy, don't feel like get up and walking around. So how do you communicate with each other like that? We don't have smoke signals or anything. We're inside. So we ended up going back to the phones and just using instant messengers or Slack on there and going out. But this brought up a question like, how do you communicate internally like that? We wanted something dirt cheap or dirt simple to work with, something we could code up in a quick time, see if we could do that. So we're like, okay, let's just start with something really simple, just a little chat program. Hundreds of them exist out there. Surely we can write something just to do that. And this started us down our path. So first thing we had to do is decide what a chat program is. It's a server and multiple clients. Well, right off the bat, that sort of sounds like a C2, but we get to that later. What does it need to do? You have client should be able to send data back and forth. Server needs to route data around. Yeah. We're not trying to recreate something here like Google Hangouts or something like that where you have private messages, you have groups. No, just simple chat. All broadcast chat. So in the process, we ended up looking through and writing something up really simple in Python. Why? Because, well, it's Python and we know it and it's easy and there's libraries and stuff. So let's go ahead and I'll just jump over into a quick little chat program here. This will be a running theme. We'll talk a little about something, do a little demo, show the code, all that. And that's my phone somewhere ringing. So ignore the phone for a moment. I don't know where it is.
It's our new chat notification feature.
Oh yeah, that's it. Yeah, no. Every step we're going through here, we'll be adding additional features to it, showing additional functionality, things of that. So go ahead and jump over into the chat demo real quick. Hold on just a second. Show you as simple as it is to write a little chat program if you wanted to. So, jump over. Assuming this is working. Okay. Yep, and that always is messing up the screen. So, let's jump into the first one here. So we have two little programs, chat and client and server. If you want to look at server, It's not a lot in there. Let's maximize that so you can see it. Basically, all it is I just got a Control-C handler in there just so I can hit Control-C and it doesn't barf everywhere. But beyond that, you just set up a socket. You listen on the socket, and whenever new connections come in, you report on it. You can type stuff in and send it out to people, and you can receive messages and reroute them to other clients. That's it. Nothing else. Same thing from the client side. It's you connect up to the server, you loop, you hear something from the server, you write it out to the screen, you type something in, it sends it out. Not much to demo, but go ahead and do something real quick here. So server 127.0.0.1.555, just a name. Yeah, okay. Down here, same thing. Every step will just be going through the same sort of stuff, just I'm not in one. All right. Stupid simple, just to demo that it does work. Yeah. Bob. All right. Here you can say, oops. You can say hi. Shows up as hi. Down here you can say bye. And it goes back. Okay. We have a chat program. Yay. It works on multiple nodes. We wrote chat. Yay. Okay.
All right. Thanks, everyone.
Yeah. No. Yeah. Okay. That's it. Goodbye. No. Well, next level along, let's go back to, where's that at? View. Does it go back to where it was?
I'm guessing not.
I'm betting no. Oh, no, no.
Your Mac has crashed.
Hey, it did. Yay. All right. So, we're super tech here, super awesome programmers. We wrote a chat program in I don't know, way more lines than is probably necessary, but less than I actually expected it to be in Python. So, but at that point, we're like, okay, we have that. What else can you do? You can do encryption. Why? Because, well, we're pen testers and we flag the customer if they don't have encryption on all of their communication. So maybe we should do that. And we're sending sensitive data over it potentially. So we go and implement encryption, and I'll probably rework this flow a little bit here in a second. And but there's a different couple of ways you can do encryption. You can do some of the standard things that some C2s out there do. You can tunnel everything over SSH. You can use SSL tunneling, stuff like that. Or you can be super lazy like we were and just use standard TCP sockets and encrypt the data packet and just send that. It works. We don't have to change anything to the chat program, really. We just add a line that says encrypt and decrypt. We got it going. I'll show that when I'm doing the next demo as well. So we'll just go ahead and skip over this. But it's one of those things that you don't have to be super tech or super elite to write a encrypted program. Just start with a chat program, add a little bit of encryption. Okay, so you got a good basis to work off of here. The next thing we realized is, through this semi-fictional story, is that while we're in the distributed environment here, Bill's over there, Tom's over there, I'm here. Sometimes I won't be able to run a command for me on his system. Maybe I want to see if it changes from his location, from my location, the output. So I ask Bill to run it. He says, I'm sorry, I'm going to get food right now. I'll do it later. I'm like, well, here, what if I can go ahead and run a command off of his system for him? Well, great. We'll go ahead and add that into our little fictional program here. Or it's not really fictional. It's a in-progress program here, a wannabe program. So we go ahead and add in, we have encryption now. We can send messages. Well, let's go ahead and add in the execution or a command execution. So go ahead and do this one more time. I'll do all the demos in a minute. That way I don't have to keep jumping back and forth. It takes up way too much time. I've got one more set here, and then I'll go into some demos. So, assuming we can execute commands, which I will demo in a moment, believe me. Well, I hope it works. It is live demo gods here. So, assuming you have that one of the other features that we said that as a requirement, most C2s, RATs, all that has is push and pull files. Well, sometimes when you're running against a program or in this environment, I won't be able to run a command for me. He doesn't have that binary or whatever on his system. Fine, I'll push over the file and then run it. Or I want him to run a command like, I don't know, say nmap. Well, if I have an input file I want him to have, I'll push over the input file or target file and say run against that, and let it run and collect the standard output of that. So let's go ahead, and now I will jump through some demos from those. So hold on just a second here. All right, let's jump into, well, I'll just jump ahead a little bit here. Let's go, yeah. Let's just go into remote command. So if you go ahead and look in here, one of the things I did on that step 2 was encrypt. We go ahead and look at the encrypt function. It is that. Like I said, it's stupid simple. All it does is it takes a string in, encrypts it. Well, I do a little bit of encoding to handle for special characters, null line characters, stuff like that. You can do that, handle it. I had to do that for network traffic. But you just basically write an encrypt and a decrypt function. For this, I'm just using an AES based on my key of should change this, which I highly advise changing that. It's going to be 128-bit AES, so longer key, larger encryption, so or more secure. I'll leave it up to you. I was demo of how simple this could be if you want to come up with your own way for key exchange. You build on one box, hand it over, write it on, whatever the case is. I'll leave that up to you to figure that out. So that's all that is. And then if we looked into, let's say, the server, where's it at? If you look like right here, that's it. To send the message, I just take it, encrypt the message, and then I send it out. So that's all I have to change in there. I add one line to do the encryption. But as you can see, I went in and whenever I type in a command, I now check to see I have that command, and was there another one up there? No, that's in the exec here. So we just have the exec command right now. I added a new feature. All right. Let's go ahead and run that. Where am I at up here? Okay, /server. I actually have that back here somewhere, don't I? Yeah. Bring that up. Let's clear this to the client. Now I can just do stuff like hi, or hi, which, no, oh well. Let's do exec, and that should be cap, exec ls. I get ls output back. It's running it on the other client, getting it back. So, yeah, I can execute commands. That's a building block. One of the things you'll notice as we're going through this is we enlarge on basically a step-by-step process. You get one thing working, then you move on to the next one, you add something else. So ultimately, we want something like a remote shell. Right now, we have command execution. That's a great step in the process. We'll be reusing this later on. You can, if I figure out where that other window went to, right here. If I cd into 03 there as well, do client 127.0.0.1, 555, and this one is going to call Tom. If I run that again up here, I do exec ls, I get double set of output from it because I have two clients. Right now it's acting more like just shotgun approach. Everybody do this, give me your output. So, okay, we're getting there. Not exactly what we want it to do in the long run, but for right now it's a working prototype. So let's go ahead and exit out of that, go up a level, minimize these again. So what was next? What was in here? Oh, file push. That's good. At this point, because we're starting to do a lot more communication-based programming, a lot more socket, pushing files, stuff like that, we pulled out some of the code that handles that, the socket communication, made a comms class. So if we look at comms, and that's not it. So it uses encryption. We pulled the encryption out, threw it in there a little bit, but it sets up our sockets for us, and that's not it. You can send broadcast messages. You can send files, receive files, stuff like that. We got the code in there. We just pulled out encrypt and decrypt message into here just to help centralize things. As your code goes, it evolves. That's what we're helping show here. So let's remove whatever is in temp. All right. So let's go ahead and run the server again. Wherever it was. All right. Got that going. Where did you go to over here? Come on, open. There, that'll work. Okay, Control C. CD. 304. Go ahead and run the client again. Okay, from up here now we can still do the exec ls, get the output back, that's great. But now we can also do push test.txt. On the client side at the bottom, you can see received file test.txt. What it actually does on the client side, I'm running it from the same directory right now, so it's kind of odd, I know, but it makes a directory called temp, and in the temp directory, it puts test.txt, appends a 8-character or a 5-character random string to it, so if there's no file collision, you can make that whatever you want. You can add a lot more error handling, a lot more stuff like that. But what we're doing is we're just showing that, okay, now we can execute commands, we can push files. You're seeing how this is starting to build up over time. Well, that's great. Next things would be like pull files and remote shell and stuff like that. And we're actually getting into that. But first, there's a few other things that we need to talk about. Go back to it. Yay, okay. One of the other things you need to worry about is at this point we're talking about we have some decent functionality in there that as a team we can make use of. It's nothing great, it's nothing that you can write home about, submit to some great tool repository somewhere, but it's something that's functional, it's utilitarian for our needs. And we've been building it up a little bit. But as we're going, we're starting to add in more libraries to it, more files, external files, stuff like that that we need to keep track of. And if we're wanting to hand it to another team member and say, here, go ahead and run this for us so we can continue on, we needed to bundle it together somehow, make it more unified, more single file, if you would. There's a couple ways out there. I'm sure there's more than what we have there, but Pi2exe, PyInstaller, things like that. All of those will take an entire Python project and bundle it down to a single binary, whether it's a Windows binary or an ELF binary for Linux, stuff like that. So you can just drop it on any system of that can run that binary type. It'll run, including all the libraries with it. Good to go. So now you're more along the lines of building agents, if you will, to drop onto systems, which, not doing the demo, but at that point we really started thinking that what we have here is getting much, much closer to a C2 environment as opposed to a chat program. We can send commands to execute, we can push files, we can have it all into one little binary so we can drop it on there. So okay, that's great. So we decided to forego the whole chat program and just get up and walk and talk to each other if we need to. It's better for us. We sit on our butts too much as it is. So we decided just to go for more of the full C2 environment at this point, see how far we can get this going in just some spare time we had on the side. So, okay, one of the first things you want to do is do ability to pull files back. Okay, you would think that would be along with the file push, but the way we actually wrote it is it was after the fact. With the file push, some of the things you need to think about is that, why would you want to do that? Well, there might be a loop file there that you want to pull back, some sensitive file in the remote system. There might be an output of some file, something that doesn't write out to standard out, but it might create a file. You want to pull that back. So there's a decent number of reasons you want to do this, and this is getting us even further down that path of where we said that base level for what sort of a C2 environment is, push and pull files. Go ahead and jump over that. And finally, I'll go ahead and bundle the demos together in a minute so I don't have to keep jumping back and forth. So one of the things that is going to finalize it is this concept of a remote shell. Well, how is this different than issuing remote commands? Well, the biggest difference is that I don't know if you've ever tried to write a remote shell. It's not as intuitive as I first thought it would be. For example, you set it up, the connection, you send a command, that's great. You get the output. You type CD, hit enter, then you type a command. Well, the CD worked, but then you're not in that directory anymore. Because each one of these commands that you execute are as a single execution, and then it resets basically the runtime environment where it's running. There's no state maintained. Writing something like netcat, where you're sitting there and you maintain state on what directory you're in, is actually a little more difficult than I first intended or first anticipated. I ended up coming up with a way around it. I don't know if this is the way other people are doing it, but it's a fairly straightforward, intuitive way for myself to come up with this. Maybe other people can make use of it, but here again, it's just showing that you can do this by working step by step. The way I ended up doing it is, when we're in the code, I'll show it one more, is on a Unix environment or Windows environment, you can basically chain commands together. Unix, semicolon in between. So on a single command line, you can type cd /bin, semicolon, ls, and it'll give you the ls output of /bin. Well, you can do that through this as well. But then, the next time you execute a command, you're not in the bin directory anymore. Well, what happens if you, instead of just leaving it at that, you append to the end of every command the command like pwd, present working directory. So now every time you issue a command, you cd into a directory, or you issue the command, and then you get the working directory back out of it at the end. Then if you stored that locally as, there's my phone again, somebody really wants me. You get the current working directory of that last command. So if you store that as a variable, then at the beginning of each new command, you prepend that to the command. So you cd into the last current working directory, issue the command that you're wanting to execute, and then store the new output. You can maintain state as you're going through and have a fully functioning remote shell. This way, even if they're typing cd into some directory, you're going to cd into the first directory, execute their command, and store what the new resulting directory is. And it actually changes very little to your code to actually do something like that. And I had worked through tons of different iterations of this, trying to figure out how to get it to work. And when I thought of that, I'm like, because I was trying to do it on the client side, have it maintain state and all different scenarios, and just coming up with a lot of issues. When I decided to do it on the server side and have the server just maintain state locally there, so the client is still just as dumb. The client just knows how to execute a command. That's all it is. The server now is the more intelligent one that knows what the last directory was and all that, and issues the command. A couple of things that's beneficial from is that the client now gets to maintain a smaller footprint, less code base, stuff like that, easier to maintain, easier to change on the road if you need to change a signature or something. But it keeps more of the functionality in the server and less in the client. You may have a scenario where that isn't ideal, but for this scenario and for this demonstration, it worked very well for us. I'll go ahead and jump in, show those last two demos, and we'll be getting fairly close, I think. So, okay, hold on just a second. Exit out. So, it's okay, let's cd, down again. Let's go ahead and jump all the way to 7. So we'll go ahead and look at, in the server side, when we were doing the file push, and I keep doing that, let's jump down to the execute for file push, or file pull, I should say. The server, at this point we have a bunch of commands in there. We skipped over a step in there as well. When we did the paradigm shift, saying that we wanted to go into more of a server and various agents out there that we want to control, we need to maintain a list of those agents out there so we can interact with them individually or as a group. So we built this concept of neighbors, or whatever you want to call it. So we added a bunch of commands in there, which resulted in us needing a little help menu. So at this point we have help, list, exec, push, pull, and shell. List just gives you the output of how many agents you have out there so you can interact with them, 0, 1, whichever one it is. The other commands, push, pull, exec, web shell, or remote shell, you can specify the agent number and it will issue the command just to it. Or if you issue a -1 to it, it sends it to all of them. It does a mass broadcast out if you want to have them all do something. So, but the pull command is, so we showed push before, but for pull, it's just a matter of sending the pull command to the client. The server is relatively dumb on this part. It doesn't really know what's going on. So the server, turns out in that scenario, didn't have to do very much, but we pushed some of the code to the client for once for the pull. When you do pull, we're basically replicating on the client what we did on the server for push, which is it goes in, it reads in the file, and sends it back. It's very simple, straightforward. We already had the code in one place. We just reversed the order. So now you're just telling it to send it back to you. Nothing big there. Go back to the server again, if I can find the right one. And then we have shell. One of the things that shell does, if I jump back up to the shell code, remote shell here, is so the remote shell. Well, I have a display prompt in there just so you can see a prompt, so you can see the difference between output of commands and what have you. First thing it does is it displays, it grabs whatever the current working directory is. It's set to 0 at the moment, but then it executes it, and so it has it coming out. It'll grab it in a moment. Every iteration through a while loop, it just sends out whatever the prompt is up there, which is remote shell exit to quit, and the current working directory. So you can see where you're at. I guess I should grab this. Sorry. And then it comes through standard style loop as we saw before with the server, just going into a loop sort of a loop, just reading in. As long as there's stuff to read in, if it's something on standard in, we take it. If it's exit, we just quit out of the remote shell. Otherwise, we come down and we decide what our message is. Our message is now CD into whatever current working directory is, semicolon, the message that we want to send, and then we append semicolon PWD to it. So that's that sort of construct that we say. You're always CDing into a directory, executing a command, and getting whatever the new working directory is. The way we get the output back is anything that's sent back comes into this else if block down here, and we're just doing it that the PWD line, the result of that is always going to be the last line of the output. So we pull that off, store that as CWD, and then everything else is just the result. Fairly straightforward, fairly concise for the most part. I'm sure there's a lot of cleanup and a lot of tidying that could make that even prettier and more functional or more concise. It is functional. It works for our needs and in our testing. And a lot of this code isn't in this format, but this was the basis for what we did with our actual command and control we wrote called Legion. But this is the fundamental core of what we wrote for that, and then we went through and did a lot of other work with it as well. So let's go ahead and see a demo here for the remote shell and what have you. So let's go ahead and where is the server, client? Oh, there should be another one over there. All right, let's go ahead and kill that. And I'll just go ahead and close those out. But this is the one I want. So you can see there, I have two different clients connected. If I type list, you can see I have two agents, 0 and 1. Okay, I want to interact with one of those. I type exec 0 ls. I get the result from that one. They're both running in the same directory right now, so the output would look identical. But at this point, you could also type shell. Well, I'll go ahead and demonstrate why I needed to do that. So I do exec 0 cd ... exec 0 ls. It's the same output. It doesn't maintain state by default. So if we do shell 0, okay, now we're in there. We're in a remote shell with a remote system. We type ls. We do cd ... type ls. It maintains state. It CDs down to the right directory. You can go wherever you want. You can, let's go back into 01 chat. Do ls there, where you can cat files. In this remote shell, in this style of format here, or this style of remote shell command execution, you can do pretty much anything you could that is not interactive. If you wanted to do something like VI, yeah, you're going to have to find a different solution for that. Remote desktop, something like that. But for anything that you can run and just get an output from, it's not sitting there waiting for you to do something, this will work absolutely fine, which is 90% or not, well over 90% of most of what I do engagement. I tend to script everything up anyway. I don't wait for interaction. If you want to edit a file, you can always use sed or something like that. Or you can just pull the file back to you, edit it, push it back up, execute it, whatever you want to. So this was one of the biggest things that took me the longest to figure out how to do was to do the remote shell. But this is also then went on to be in parts of other code, just various versions of it, written it up in ASP and Java and what have you else. But the thing is, it took us a while. I would say there was a lot of other coding going on, other aspects of it, which we'll talk about in future things you could do to this code if you wanted to run with this. But it took us over, I don't know, a couple months of just spare time, afternoons, evenings, wife is asleep, sit there and code a little bit, stuff like that. If you were dedicated to this, you could probably write all of this in a matter of a couple of days if you really were just sat down, did nothing else. Or if you're even better than me, you could write it in a matter of hours, I guess, or less. But so this is where we're at right now with this code. So let's jump back over. I'll also send out a link after a while as well from my Twitter as far as to the link where the GitHub where this code will be up there at, as well as the more full-featured, more final product of Legion. You can get to it as well. You'll see remnants of this code in there, such as the remote shell. You'll see something reminiscent of that, and all these features will be in there if you wanted to look at that. It, too, is not written as a complete, like, this is the most badass command and control out there ever, but it's functional. It's something you can control inherently, and it's a good base to build off of. You can easily add extra features to it, whatever you want to. It has stuff like port scanners and stuff like that built into it, which this code doesn't, but this is help illustrating how you can get to that point if you wanted to write something yourself. So, one of the things that we were, at this point, you have a base. You have the absolute bare minimum utilitarian command and control if you wanted it. What could you do from this point? You could do whatever you wanted. You could add extra commands in there, like I said, a screenshot or port map or, I don't know, wget or something like that. You could build something like that in. You do alternate communication paths. You could do like ICMP or DNS, stuff like that, whatever you felt that was necessary for your environment. We went down the route with this of just straight TCP sockets because it worked for the demonstration that we were going for, and in most scenarios that'll actually work. Now, the next thing down there is one thing that would help in scenarios where straight TCP communication from point to point isn't going to work. That would be in the scenario where you have multiple home networks or multiple networks with multiple home systems. We'd like to see somebody or ourselves go in and add in like SOX proxies or pivoting functionality, so you can say, okay, that agent is sitting on two different networks at the same time. We want to tunnel through it to go ahead and do something else and communicate. That would be nice. It shouldn't be overly difficult to do. We just haven't sat down and done it with this code yet. Mesh networking. That's one that we do have a base functionality in on the more complete project of Legion. Whenever you go out, you can deploy an agent and point it back to the server. That's fine. Or you can just start deploying agents without any server associated with them. What they do is they then do a multicast, find other ones like themselves on their multicast network. If they find any, they link up and form a network. Then at any given point of any one of those can find a server. Now the server can contact all of those. It has a sort of pivoting involved, but not really. It's just more just message forwarding, going through to each individual node. But that's a great concept that I don't see a lot of people using. It's more of just, you go through and you just pepper a bunch of agents down across the network, and then they start communicating amongst themselves, and at some point in the future, you set up a server, have one of them connect into you, one of them is beaconing out or something like that, not all of them, just one, and if it can get out to you, then you have access to everything it can, all the other agents. That's something that isn't that overly difficult either. It took a little bit of a thought process in there. It's a little more complex than the rest of this, but it's something that you could take this code and build it into something like that easy enough. We did it. Lots of other directions you can take this, or you can just keep something like this, bare minimum, and run with it. But as I've been going through this, the talk has been sort of around doing a C2, something like that. But at the same time, I've been going through and also hoping people can understand that you can write something that is fairly functional, fairly utilitarian, but you don't have to write it all at once. Trying to write something that does all of it at once can be a little stressful, can be a little daunting, especially if you're not new to programming, stuff like that. But if you start with something simple, like, say, a chat program, then add a feature to it. Add another feature to that and keep going. Eventually, you can get to something that is way more complex than anything that you could have written just sitting down one day and just say, I want to write this. So if you take that approach with whether it's writing a C2 or writing your own, I don't know, some other program out there you want to do, a web server or a phishing program or whatever, just start with something small and keep adding to it and testing each step along the way to ensure that it still works. And you'll get to something bigger and more complex and more functional without the stress of having to worry about writing it all from scratch the first time. I've been doing programming for many years, and I've done both ways. And it's if you have the time, start small and start building the project up. You'll end up saving time over the long run anyway, probably.
Yeah, because under the hood, this is still just a chat program, right?
Yeah. Ultimately, everything we've shown there is still just a chat program. You can still send messages back and forth and all that. Same basic functionality. You're just having a server with clients connecting in, and you're sending data back and forth. It's just we are adding extra features in those commands, certain keywords like exec or pull or push or something like that. So you just keep adding to it as you go along, and it's going to grow and grow. Now, are you going to take this code or even Legion and go out and like hack networks with it? Probably not. But it's there as an example or as a demonstration or as a kernel that you can build off of and do other things. So that's did a little bit of a quicker way through it by not jumping back and forth between the demos all the time, which was getting really frustrating for me. But thank you very much. You have my contact up there, my link, Twitter. Bill doesn't feel like he doesn't believe in Twitter. He thinks it's imaginary. So if you have any thoughts, questions, comments, criticisms, banana puddings, I don't care. Just let me know. Bill, got anything?
I don't have anything else.
All right. Well, we appreciate your time coming out. Hope everybody who stuck around at least enjoyed it a little bit, might have had something to think about. So we appreciate it, and thank you, and have a great rest of your day.
Thanks.